Okay, Assalamu alaikum, Bismillahirrahmanirrahim. In the last class, we started discussion related to the some important properties of expected utility function. And regarding the expected utility functions, we tried to prove continuity and independence. Clear? And first of all, just recall that with respect to the independence, why we assume the property of the independence in case of the expected utility functions means that every expected utility function is independent to origin and scale. And why we assume that important property, or why that was the assumption of the expected utility functions, or we call that expected utility function is the von Neumann and Morgenstern utility function as well. And because of compound lottery, and when we add up different convex combination of the lotteries, so we assume that the third combination or the fourth combinations will not affect our the behavior or the preference level being a decision maker. So that's why we assume that any combination of the lottery will not deviate with you from that selected lottery. Why we assume that? Because we have the important assumptions behind the decision maker, that was the rationality of the decision maker. And whenever we impose we are a rational individual, ultimately we can compare, we have a continuity and the consistency in our nature. That's why we have realized that combination of lottery. So another combination of lottery, either you add or subtract, will not affect your behavior. And similarly, in case of the continuity, continuity means if you have two extreme bundle of lotteries or choices, for example lottery P Q R, so R is the highest lowest level of payoff. Similarly, P has the highest level of the payoff in term of the probabilities values. So and Q is the middle of these values. So Q, when we take the linear convex combination of highest and the lowest value of lottery, so consumer will be indifferent between the middle of lottery with respect to that combination. So why we assume that continuity? That continuity we impose to prove the existence of utility function. Acha, देखो, first of all, von Neumann and the Morgenstern did not focus about the continuity of the utility function. The continuity of the utility function is measured focused by Debus's theorem in 1950. In 1950. What was that theorem? That is a preference relations these are the actually the binary relations with a real valued function that is called a utility function. Over the set of finite number of alternative alternatives. These are lotteries P1, P2 and Pn, which belongs to is space of lottery, have a utility function if and only if there is continuity. There is continu- there is continuity in choices or behavior. Okay, so it means that in case of discontinuous and infinite set of alternative according to the W's theorem, there will no existence of the utility function. Okay, so we have already proved what is the continuity and what is the finite set of the alternatives to prove the utility function. And for example, if P and Q are two alternatives and P is at least good as Q, implies that utility of VZ into P will be Z belongs to Z such that P at least good as utility of P will be greater than utility of Q, and utility of P is equal to sum of Z belongs to Z and P V Z that is strictly greater than utility of Q, which is equal to Z belongs to Z and Q V Z, and these are called Bernoulli numbers or von Neumann numbers. Von Neumann numbers. Okay, so that value of outcome which we assign subject to the utility functions, it is called Bernoulli numbers or the von Neumann numbers. Now, on the basis of this discussion, and first of all, you need to discuss about the nature of utility function. Okay, what should be that nature of this utility function? First of all, because in case of certainty or uncertainty, the nature of utility function is same. First of all, the difference between uncertainty and the certainty, we don't have any value of the probability assigned with that value of outcome. This is our value of outcome, which may be $10, $100, and whatever. And what expect depends on this value of the probability, which we have discussed. In case of the certainty, you don't have this thing. Same kind of the utility function you have here. In case of the discrete case, same kind of the utility functions, and that utility function again you have the Cobb-Douglas and something else. Clear? Normally we have a CES, constant elasticity substitution function. Clear? That is called CES. CES, constant elasticity substitution function. And that CES, constant elasticity substitution function, you may discuss in case of production function or in case of consumer theory. सही है. So on that constant utility, constant elasticity substitution function derive या divide into Cobb-Douglas, similarly Leontief and linear. Okay, Cobb-Douglas, Leontief and linear utility function. That depends on the CES, constant elasticity substitution utility function. And similarly, what should be the nature of this Cobb-Douglas utility function or the Cobb-Douglas production function or the that Leontief production function? So there are some important properties that we need to discuss here. So now we are starting the nature of expected utility function or the simple utility function. Okay, what should be the nature of utility function? Clear? So now just I recall you, okay, what is the difference between, in previous case we derived the expected utility function. In case of the expected utility function, we did not discuss, we just discussed the properties के independence and continuity. And that independence and continuity, why it is important, that was focused by the W's theorem. Okay, to prove the existence of the utility function, your sets of alternatives should be finite, and you have to prove the continuity in your choices of bundles. Second important thing is that, okay, now what numbers, like in case of the cardinal utility function ना, जो हम कहते हैं कि भाई we assign, because utility is your psychological behavior. Technically we cannot measure it. हम नहीं measure कर सकते ना कि what kind of the utility now you are availing today after this class, or what kind of the disutility you have now. So it depends on, clear, your perception or your psychological behavior कि what value you assign. Clear? Every individual assign the different value. You are sitting here, you will weight different, she will weight different, depends on your behavior. Okay, either you like or dislike, right? And similarly, okay, that number which we assign here, these are called Bernoulli numbers or the von Neumann numbers. उनको हम Bernoulli numbers or von Neumann numbers कहते हैं. That's why these utility function also called the Bernoulli or the von Neumann utility functions. So main theme is expected utility function, and that expected utility function, when it derived through two important axioms. What were the axioms? Independence and the continuity, and we name that expected utility function or simple expectation, because expectation we discuss in statistics as well. वहां पे भी हम डिस्कस कर रहे हैं कि how you find the expected value of your outcome. We discuss in statistics or the probability. But here we prove with respect to the some axioms. What are these axioms? Independence and the continuity, and we call these utility expected utility function by the name of expected Johnston utility function, or the von Neumann utility function, and the Bernoulli utility function. Clear? So now we are moving the nature of utility function, which will be applicable as well as in certainty or in production. Clear? तीनों के अंदर applicable होगी जो we are discussing here today in case of uncertainty. Of now the nature of expected utility function. Okay. Up now, first of all, basic concept is that when we talk about the optimization, so as far as optimization is concerned, we assume that our function is concave. Clear? So for optimization or the maximization, for optimization or we can maximization, maximization, the objective function should be concave. Concave. And sometime another kind of assumption we have to assume, or we can another kind of assumption is quasi concave. Now, what is the difference between concave and quasi concave? It is a little bit technical debate, or why we assume that the function should be the quasi concave or instead of the concave. And when we talk about the concavity of the function, it is the concept that we talk about with strictness, or the we assume that our function is strictly concave. So we are not relaxed, but it is not necessary. Why? When we talk about the concavity of the functions, so first of all, just recall it. Okay, the nature of function should be like this one. So then you will have a concave function. What is theoretical assumption behind this shape? First of all, we assume that at the initial stage, your production or your utility and whatever you have, objective, increase with decreasing rate. Increase with decreasing rate. Clear? And but it is not necessary in everywhere or in every case you always assume that your function will increase with decreasing rate. There are other possibilities.
सर बट फॉर कंज्यूमर तो सही है ना, डिमिनिशिंग मार्जिनल यूटिलिटी होगी बिकॉज
देखें, कंज्यूमर डिमिनिशिंग मार्जिनल यूटिलिटी होगी, बट जनरली फॉर एग्जांपल व्हेन वी ड्राइव के लेट्स से हमने कहा कि ये यूं है, ठीक है, अब मनी मैट्रिक यूटिलिटी फंक्शन है, ठीक है, देयर इज नो डिमिनिशिंग मार्जिनल यूटिलिटी देयर,
कांस्टेंट
सही है, इट विल इंक्रीज, सही है, इन केस ऑफ द मनी मैट्रिक यूटिलिटी फंक्शन, so the diminishing marginal utility is not applicable here, or if you are addict, ठीक है, addiction of opium and some drugs, so that concept will not be applicable there, clear? So it means कि it is not necessary, you have to discuss the journal aspect of the function, or that was a utility behavior, or in case of the production all the possibilities are here, सही है, clear बिल्कुल. So अब now, so it means कि so there is the possibility कि initially you will have like this shape, clear? So what does it means कि your utility or the whatever means कि function increase. If we just talk about in mathematical term, then we will discuss with respect to the economic theoretical definition. So increase will decrease, increasing it, ठीक है, any nature of the function, we don't know either it is the utility function or it is a production function, clear? Or you may have this kind of, the nature is कि it increase with constant rate, clear? Whatever the function, we assume that it is your x and that is the function of fx, and similarly it is the function of fx, and similarly x, and this is x, and okay, and in that was the optimization, with objective is maximization. Optimization, the objective is minimization, it is another debate, clear? Here the condition are entirely reversed in case of optimization with minimization, clear? Both are the part of the optimization. Optimization means कि you have to find out the best level of choice. So best level of choice in case of cost will be the minimum value, ठीक है, and in case of the output will be the maximum value. So both are the optimization, clear? So first of all, remove that misconception कि now the optimization is just to maximization. Optimization is the best solution, clear? The best solution. So that's why we talk about the duality, not the uniqueness. We normally talk about the duality. Duality means कि we have both objectives simultaneously, minimization as well as maximization. अच्छा, अब ये सारी चीजें माइंड में रखना, इसको फिर हम थोड़ा सा टेक्निकल चीजों से रिलेट करेंगे, क्लियर? अच्छा, अब देखो, तो इट मींस के अगर फॉर एग्जांपल लेट्स से वी हैव दिस फंक्शन, so first of all we have the concavity. So now it is clear, as far as concavity is concerned, it means कि we are strict. What are the restriction or strictness here? Strictness is here कि we assume that कि our function is increase with decreasing rate. That is our strictness here. सही है? So we are not relaxed. So it is not the weaker assumption. ठीक है? ये whenever you read a masculine, तो they will point out कि concavity is not a weaker notation, it is the strict notation. सही है? What is the meaning of strict notation? Means कि that is your strictness, कि you assume that increase with decreasing rate. It is not the weaker notation. Clear? So when we talk about the weaker notation, it means कि we assume that कि there is the possibility of these two things other. Clear? So we relax. So now, first of all, here we talk about the concavity. जहाँ रिपीट करवाना हो बता दिएगा। That is the x vector or choice variable, vector of choice variable. You can say that vector of choice variable. ये भी मुझे रिकॉल करवा दीजिएगा। वी हैव टू डिस्कस दी वेक्टर स्पेस। इट इज इंपॉर्टेंट, यू शुड नो अबाउट वेक्टर स्पेस। पता होना चाहिए बीइंग अ पीएचडी स्टूडेंट के व्हाट इज द कांसेप्ट एंड व्हाट आर द एडिशन एंड सब्ट्रैक्शन ऑफ द वेक्टर स्पेस। ये पूरी बिगेस्ट पूरी ऑल द डिस्कशंस आर बेस्ड ऑन वेक्टर स्पेस in microeconomics. So we will have discussion. I think we will cover in 2 lectures vector space in detail. Okay. So x is a vector of choices, and this is, for example, fx. Okay, and we assume that now x double dash x dash. Okay. Yes. Sorry. इसको थोड़ा सा just a minute. Just
डिग्री में था पहले।
yes, just a minute. Right. Okay. So now we have x dash, and this is x bar. Okay, that is equals to it is equal to actually the alpha x dash plus 1 minus alpha x double dash, right? Linear combination of this one. So x bar equals to this one. So when we apply this, so ultimately that is actually the equal to, we can say that alpha f x dash, right? And this one is 1 minus alpha f 1 minus alpha fx double dash, right? Double dash. Okay, and what about this one? It is actually, right, this value. So this value is something like f alpha x dash, because and plus 1 minus alpha x double dash, right? Because on that line it is actually the linear combination, right? So alpha x dash plus 1 minus alpha x double dash. When we apply the function here, so function of f x dash plus 1 minus alpha function of x f x double dash, right? And this is the value of overall this value, that function value. Clear? So on that function value, so what about this one? Function of alpha x dash plus 1 minus alpha x double dash. Am I right? Clear? So what should be this one? This is the sum of functional value of linear combination. Am I right? Sum of functional value of linear combination, or sum of linear combination of functional value. Right? Clear? And functional value of linear combination. Clear? That is your linear combination. We apply overall function when it lie on the top of that function. Clear? So now you apply that function. Why? क्या करते हो? यही करते हो ना कि भाई that is the function, that is domain, and domain of function yani function at this domain, right? And similarly, for example, it is fx double dash. So what about this one? This is function of x double dash x. Clear? So it means now function, apply the function over all this one. So that is this. Clear? So but here it is what? The linear combination lie between this one. How you break that linear combination? Alpha x dash plus 1 minus alpha x double dash. Then to you separately apply the function here. Function of this and function of this. And take the sum with linear combination. Clear? बिल्कुल, right? So I can write the definition is here.
सर एक चीज
Yeah.
सर ये एक जो एक आप दोनों अलग अलग पॉइंट्स है ना, मतलब एक कॉन्केव के ऊपर एक पॉइंट है टच कर और एक लीनियर पे, मतलब उन दोनों का डिफरेंस क्या है हुआ?
वही तो मैं बता रहा हूँ. देखो that yes, देखो difference is that कि what was the convexity is here. Convexity is here कि we select 2 point. Clear? Recall your lottery. What was the lot in case of the lottery? We select P and Q. P, Q, R. These were 3 lotteries. Clear? We assume. And what were the conditions there? P. Am I right? Yeah. Clear? So these are 2 extreme values. 2 extreme values. Clear? So as per the transitivity, so ultimately when this value all it means कि you that condition implies that कि Q is also preferred on R. That is the transitivity is here. Clear? According to the transitivity. यही assume करते हैं ना कि now what we say that it is the middle of this one. When we take 2 linear combination कि हमने कहा कि भाई we assign weight this one alpha. What is the probability to play? What we call it कि probability to play lottery 1 or lottery 2. 50% chance, recall the compound lottery. 50% chance to you select a probability or lottery 1, and the 50% chance to select the lottery 2 depends on your outcome. Clear? So now, because what we assume, it is a fair, ठीक है, fair trial, not the biased. We assume कि now you have a fair coin toss. Clear? Not the biased, right? That was the assumption. So, and we assume that every lottery has a max equally likely outcomes, or the equally likely, yani that is your assumption. Every lottery is equally likely. Equally likely means ke both lottery has a same chance of probabilities. That is our assumption. Clear? So it means ke alpha and something else. So हमने यही कहा था ना कि alpha p plus 1 minus alpha, that was r. Clear? So it is the linear combination. ठीक है? And if it is the linear combination, so it means कि you should be indifferent between alpha p plus 1 minus alpha r. That was the continuity assumption of the continuity. Clear? That was the assumption. And recall this, if it is you are not indifferent here, ठीक है, so it means कि you will have a discontinuity in your preferences or the gap in your choices. So it means कि if you have a discontinuity, so you cannot plot this kind of the continuous function, whatever it is, utility function, or it is something like s, like other. Clear? बिल्कुल. So you will not, you cannot prove that. So it means कि that you have to assume continuity. अब इधर आ जाओ. अब हमने कहा कि same kind of the linear combination we select here. Clear? बिल्कुल. Two, in mathematical term, these are two neighborhoods. That is the lowest neighborhood. It is the highest value of neighborhood. Clear? Neighborhood of x bar. X bar is what? It is the linear combination of two neighborhood points of its domain. Clear? Domain that belongs to vector x, choice variable. So x double dash, x dash, and we take the linear combination. Clear? Right? Now that linear combinations, we, when that lie here. Clear? ठीक है, यही करते हो ना. F x dash, this one, it is subject to the functional value, subject to this domain, and similarly subject to this domain. Clear? It is your functional value is what? F x double dash. It is basic rule of thumb for mathematics. Similarly, what about the function of this one? It is the function of lambda alpha x dash plus 1 minus alpha x double dash. Clear? Right? So what name for this one? I can recall it the functional value of linear combination. Am I right? The functional value of linear combination. I can say that. Now, what about this one? The functional value of, just a minute, f that, yani if we sum or apply is here. Clear? So what we need ultimately, it is not lie on that. Clear? So how you can distinguish? It is alpha fx, right, plus 1 minus alpha f x double dash. What I am doing, I am saying कि now you are taking the linear combination of what? Function of fx or function of fx double dash. Clear? Now you are taking the linear combination of this one. ठीक है? So what can I say that? Sum of linear combination of convex combination. सही है? Sum of linear combination of functional value of sum of linear combination of convex combination. Functional value of या sum of linear combination functional value. Sum of linear combination of functional value. Clear? Right? And sum of functional value of linear combination. Clear? बिल्कुल. So if this value is greater than this one, so it means कि you need to prove, यानी you have prove here concavity. Clear? You have proved a concavity, right? So up theoretically, what definition I can write here? Now, consider a function of n variable. Clear? That is f x1, x2, xn. It it is defined over A and A is a convex set of R n. So such that so yeah. So theoretically we can write in case of n variables, because I cannot plot the case of n variable here. So that's why I have selected any two choice variable in the from vector x. Clear? So generally you can write in this way. It is from masculine. ठीक है? So consider this one. Ab now, what about this one? A is defined over A, and A is convex set of R. So you can write in this way. So what about this one? Because you write here, okay, that is the positive real number. So that's why I'm such that xi either it is equal to 0 or greater than 0. So yeah, never less than 0. Clear? So that's why I impose this restriction here. And why I assume the convex set? Because we talk about the nature of set is convex, because it is one important property of our feasible sets. So all the discussions based on convex set. Clear? So non-convex set, it is not the part of our discussions, because we have proved that in case of non-convex set, some linear combination will not be the part of our functional value. We cannot define it. सही है. So when we cannot define it, so you cannot find out the functional value in that region or at that value. Clear? So that's why you have to assume the all sets are convex sets. We have discussed. ठीक है? So non-convex sets are, it is not the part of our discussion in any case. Clear? So now move forward. Definition is here. The function f is real number defined is defined on the set of defined on the convex convex set A. So that is A, the subset of R plus 1. It is concave if and only if alpha x dash plus 1 minus alpha x double dash greater than equal to alpha fx dash plus 1 minus alpha fx double dash all values of alpha belongs to 0 and 1. So the function is concave, not strictly concave. Okay, if you have strict inequality, means ke you don't have this one. Okay, strict inequality. So that is called strictly concave. Strictly concave in that case. Strictly concave. Strictly concave. In case of strict inequality. So now that is actually it is a strictly concave function. Okay, why? Because linear combination of this function never be equal to this value, all the linear combination. But in case of another shape, for example, like this one, like this one. Clear? You got my point. This is here. It is not strictly concave because some of the linear combination when we move towards upper side of this function, so they will be equal to each other. So there is the possibility greater than and equal to both.
फंक्शन के अंदर फिर वहाँ पे रख इसको स्ट्रेट नहीं कर
नहीं,
सकते
ये हम इस तरह जो हम कह रहे हैं कहीं पे भी जाएंगे ना, ये थोड़ा सा ये यूं,
इसका जो अपर
हाँ,
कर्वेचर आएगा वहाँ से
ये यहाँ से ना ये, तो ये यूं, इसको थोड़ा सा मैंने प्लॉट करने में वो हो रहा है, इस तरह आता जाएगा, ये इस तरह ना थोड़ा सा कर्वेचर इसका डाउन होगा, तो एक वक्त आएगा इतना स्प्रेड यानी स्प्रेड हुआ होगा कि यू विल हैव द पॉसिबिलिटी ऑफ इक्वल पॉइंट्स,
ये
हाँ,
मल्टीपल पॉइंट्स मिल जाएंगे
क्लोज रहेगा
क्लोज डाउन, तो देयर इज ऑल द पॉसिबिलिटीज इज हियर. और इसमें क्या होगा अगर कंप्लीट
सिंपल एक ही होगा
ये सही है. अब देखो नाउ देयर इज द कंसेप्ट ऑफ यूनिक ग्लोबल मैक्सिमा.
वो एक ही होगा
Exactly. There is a maxima. Maxima may be multiple. It is not necessary you will have the single point. When we talk about the global maxima, it means कि among the all neighborhood points there is no other possibility of maximum points.
स्ट्रिक्टली कनकेव में डिफरेंट पॉइंट्स एक ही जैसे मिल सकते हैं.
Strictly concave में now you will have a unique maxima that is called the global maxima.
ये वाली जो कंडीशन है
इसमें
strictly
you
नहीं है.
it yeah it is not the global maxima, it is the maxima but it is not the global maxima.
कंट्री मैक्सिमा करना है इसको सिंपल इंडिविजुअल मैक्सिमा.
बस ये आपके पास ये यूं हो रहा होगा, ये ऊपर जाकर ऐसे हुआ,
ऊपर
अब ये यूं हो रहा है, समझ लो ये इस तरह था, वो ये ऐसे ये प्लॉट करना था, वो मैंने नहीं किया. एक्चुअली मिटाकर मैं प्लॉट करता तो नाउ यू विल हैव लाइक दिस वन, समझ रहे हो, ये इस तरह का होगा. अब आप कर लो लीनियर कॉम्बिनेशन, मैंने यहाँ से लिया, हाँ अब यहाँ से लिया लीनियर कॉम्बिनेशन, ये आ गया, दैट इज योर मैक्सिमम पॉइंट. ठीक है, अब नाउ मैं मूव करते जा रहा हूँ तो यू विल हैव सेम पॉइंट ऑफ दिस वन. वो रब करके बनाता तो प्रॉपर बन जाता, अभी मैंने उसी पे किया तो नाउ यू विल हैव द सेम पॉइंट. क्लियर. तो अब यहाँ क्या होगा, नाउ यू विल हैव द मल्टीपल मैक्सिमम पॉइंट. सेलेक्ट दीस नेबरहुड्स. ठीक है, so when you select these neighborhood, so that is your maxima, it is maxima, but these are not the unique maxima. So that's why we called it maxima, not the global maxima. That is the technical difference, maxima and the global maxima. This concept is discussed in alpha C theorem.
ये पहला वाला था वो ग्लोबल मैक्सिमा.
Exactly. Okay. अब now one important thing is here. So yeah, the technical word is not the normal, it is just maxima. Clear? It is maxima, that was the global maxima. Global maxima always will be a unique maxima. Ab now one important thing, it means ke what is the property of the well-behaved function. The well-behaved function in mathematics, we don't care about you will have the multiple maxima point, you don't care about. But in case of the consumer preferences or the decision maker, either that decision maker is the part of producer theory, is a part of consumer theory. So we assume that it is a rational individual. So as far as rationality is concerned, clear, so it means he can compare the which one is better, which one is the worst choice. Clear. So in that case, so we have to define a global maxima, because to achieve a well defined function. Clear. Because it is one important property of the Marshallian demand function in consumer theory, or in case of the Hessian demand function in consumer theory, or in case of the input demand function in case of the producer theory, long run demand function in case of the producer theory, so or output supply function in case of the producer theory. We assume that your answer should be the unique answer, so we have to assume a unique maxima or minima. ठीक है, so that is called global maxima, that's why.
एक चीज का कुछ पूछना है.
Yes.
सिंगल मैक्सिमा मल्टीपल मैक्सिमास आते हैं, वो स्ट्रिक्टली कॉनकेव में
नहीं, the multiple maxima you will not have a in case of the strictly concave. Strictly concave means that you will have the unique solution, global maxima.
सही है. और जिसमें वो इक्वल टू वाला होता है वो सिंपल मल्टीपल वाला है.
Exactly.
ये वाली फंक्शन.
Exactly, that is इसीलिए I call it concave, just. ठीक है, not the global maxima. So concavity is concerned, only the weak concavity is concerned, that is maxima, just maxima. It is not the global maxima.
हमने जो पहले बनाया था वो स्ट्रिक्ट बनाया था डेफिनेशन में हमने उसको जो है वो सिर्फ
हम
concave
एग्जैक्टली एक जर्नल, तो दैट इज द जर्नल डेफिनेशंस, ठीक है। सो अब नाउ सिमिलरली we have a journal cases here. So so if we have collection of vectors that is x1 vectors belongs to a,
सर इसके बाद क्या 5 मिनट का ब्रेक हो सकता है?
yes 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 sure आप लोग ताकि जाग जाइएगा, ठीक है। x2 vector this one and xk, okay, and this is actually the part of and similarly all values of alpha 1 alpha 2 alpha k belongs to 0 and 1. So alpha x1 plus alpha 2 x2 plus alpha k xk functional value. Clear? So that is actually the case of n vector space. Generally, you can write this one. So, in case of the convexity, what does it means? That condition will be reversed. Okay? So, if the function is convex, okay. So, why we discuss the convexity? Convexity is concerned related to the minima or the production, means के cost. Okay, so in that case the condition will be reversed. So it is alpha 1 x1 plus alpha 2 x double dash plus 5 plus x k less than equal to. Oof. The function is convex. This is the condition of convexity. Now we have to move towards the quasi-concavity and the quasi-convexity. So before starting the discussion related to the quasi-convexity, you have to discuss some technical concept of geography that is called upper contour and the lower contour set, and level sets we'll discuss. Then you can define which function is quasi-concave or quasi-convex. Otherwise, you cannot discuss this one. Clear? So just break for 5 to 10 minutes, then we will start, inshallah.